No a my jsme vám slibovali zahraničního hosta a zahraniční host je tady a vidíte, že když jsem říkal, že to je takový Sean Connery of VMware, ladies and gentlemen, tak jsem nelhal. Na obraze už vidíte Cormaca Hogana. Hello Cormac, can you hear us?
I can hear you. Can you hear me?
Definitely. Where are you right now?
I'm in Cork, which is on the south coast of Ireland.
Okay, I introduced you as the Sean Connery of VMware because you look like that, definitely.
Okay.
And my question is, if you had the power like 007 in the IT world, like the license to kill something from the IT world, what would it be? What would you erase from the IT world, definitely?
Well, if I had the power, I would erase COVID because I would prefer to be doing this in person with you, like we did at the user group meetings in the past. But
Okay.
now we are resigned to doing things through, various conference calls or WebExes and Zooms, and I think almost at this stage everybody is fed up with doing that and would like to get back to doing things in person once again.
Let's hope we can do it as soon as possible. Now it's your time for your presentation. So now we switch to your presentation and enjoy it.
Thank you. So hi, everybody. My name is Cormac Hogan. I work at VMware, obviously, and I have been concentrating very much recently on Kubernetes. The purpose of today's presentation is really to give you a lowdown on some of the things that we are doing at VMware around Kubernetes, including some of the announcements we made at VMworld 2020. So let's have a look at some of the things that we're going to talk about. I do want to touch on some of the really cool things that we're doing on Fusion and Workstation. You might think of these as more developer orientated, but not necessarily. There's also some really good tools there for administrators as well. So I'm going to spend a little bit of time on that. Now, earlier this year with vSphere 7.0, we announced vSphere with Kubernetes. That was only available through VMware Cloud Foundation. So one of the major developments is how we have made vSphere with what we're now calling TANZU available not just to VCF customers, but also vSphere customers. So essentially everybody will be able to leverage it as of 7.0 U1. So I'm going to talk to you about some of the different prerequisites there are with vSphere with TANZU, and then I have a demonstration that shows you how to actually deploy it. And then what we will do is we will deploy a TANZU Kubernetes grid guest cluster inside in vSphere with TANZU. And then I'll finish off. My background is particularly in the storage area, so I want to talk to you about some of the developments that we have been doing with, or what we call our CSI driver, which is essentially the storage driver that we have in Kubernetes that allows Kubernetes to consume vSphere storage. So that's those are the main topics of today's presentation. So we'll start with a look at Fusion and Workstation and what we're doing in the cloud native space there. The first thing I want to highlight is that we now have a utility built into Fusion and Workstation that allows you to work directly with containers. So the tool is called vCTL. It comes with both Fusion and with Workstation. And what it does is it powers up what we call a Nautilus container engine. And then that allows you to do basically all the kind of container processes and procedures that you would expect to do. So to be able to pull down containers from external registries, be able to push up containers to external registries, start, stop, query, run, all of those kind of things are now built into Fusion and Workstation. So that's quite interesting for sure. Now that became available in version 11.5 of Fusion, 11.5.5 actually, and Workstation 15.5. That was a little bit earlier this year. Now, one of the more recent announcements is actually having Kubernetes inside in Fusion and Workstation as well. And how that has been implemented is using a feature called Kind, or an application, I guess, called Kind, which is short for Kubernetes in Docker. So essentially what this is standing up a Kubernetes cluster as a set of containers you could almost equate it to how we do nested ESX deployments using VMs. It's a similar type of concept. But what it means is that now, rather than deploying Kubernetes on your workstation or your desktop or whatever, if you have Fusion or you have Workstation, you can actually stand up a Kubernetes cluster and just get familiar with it and do some development work or whatever the case may be. So that is a really nice enhancement to those products. Now, you might think, well, this is all very good for developers. What does it do for the administrators? And what's happening in the administrator world is the emergence of this thing called GitOps. So actually using Kubernetes, GitHub, manifest files, YAML files to actually trigger changes in the infrastructure. There was an excellent VMworld 2020 session. It's called KUB 2306. And what that did is it took you through a scenario where a customer modified some changes to his Kubernetes clusters locally. It could be perhaps on Fusion or Workstation. And that got pushed all the way out into the infrastructure. So it could be something as simple as just resizing a cluster, creating a new cluster, deleting a cluster, whatever the case may be. But it took you through the process of creating the infrastructure as code, so a set of manifest files that represented your infrastructure, pushing that up to GitHub, GitHub calling a webhook into something like via realized code stream was the example the guys used, but it could be any other continuous integration platform like Jenkins or something like that. And that, in effect, making changes out in your production environment. So really interesting on how how we could use this GitOps concept to actually make changes in infrastructure. So I'd highly recommend checking that out. But the other thing that comes to mind is, even if it was the developers that are doing all of this stuff with Kubernetes, with Docker and so on, what does that mean for the vSphere administrator? Well, the point is, developers don't typically worry about the things that we worry about as vSphere administrators. I've just put together very quickly a list of things here that are still very relevant in today's cloud-native world. So it doesn't matter whether you're building virtual machine workloads or whether you're container loads to put into production. All of these things are still very applicable, and they fall under the remit of the vSphere administrator to be able to provide this sort of ability to control what the application is actually doing and how the application actually behaves. And this is sort of why we developed this vSphere with TANZU, vSphere with Kubernetes, is to provide a vSphere administrator visibility and management into Kubernetes running on top of the vSphere platform. So with that in mind, let's go on and have a look at vSphere with TANZU and VCF with TANZU. Now, I did mention that in vSphere 7.0, earlier this year, we released the vSphere with Kubernetes solution that was only available in VCF. And there were real reasons for that as well. So I just wanted to talk you through how we initially released this product, and it continues to be available in VCF today, by the way. So we're talking about VCF. VCF is just our easy button for standing up your software-defined data center. So it pulls together the vSphere environment for compute, NSXT for your networking, possibly vSAN for your storage as well. And then you have vRealize sitting on top of all of that for the management and monitoring and automation and so on. Now, the main things that we introduced with vSphere with Kubernetes, one of these was to have containers as first-class citizens on vSphere. And this is where the vSphere pod service comes in. So essentially, we had these pod VMs, which emulated what containers do. So you could pull down a container image from a Docker registry or whatever, and you could stand it up very quickly. We supported that ability to stand up container images in vSphere through this vSphere pod service. The network services, obviously, pods in Kubernetes need to be able to talk to each other. They need to be able to, be able to talk to the outside world. These network services all provided by NSXT. The other thing we had is a registry service. So rather than going externally for your container images, we provided Harbor as part of vSphere with Kubernetes. The Harbor registry allows you to keep container images securely on premises. And last but not least, the storage services. This is what is provided by our CSI driver, essentially the ability for containers to have a persistent volume, persistent storage, should they be a stateful application. And so that's a CSI driver is what we developed to plug in there. And of course, on top of all of that as well, we needed the ability to deploy TANZU Kubernetes grid guest clusters. Now, when we talk about the pod servers, we're essentially working at what we call the supervisor layer. But there's also another layer that provides developers with a very upstream Kubernetes-like experience. So instead of using pod VMs, which is what you would get at the supervisor cluster layer, you would get ordinary run-of-the-mill containers in a TANZU Kubernetes grid cluster. Of course, wrapped around all of this then is APIs, the ability for the developer to use the standard kubectl commands to be able to interact not just with the supervisor cluster in vSphere with TANZU, but also with the TANZU Kubernetes grid guest clusters as well. So that was essentially the VCF approach. And you can see that there's a lot of things in there like the NSXT that we automated with VCF in order to make it very, very easy to consume. But what we announced in at VMworld 2020 in the 7.0 U1 was a slightly different approach. Oops, gone too far. This is vSphere with TANZU. And you can notice that there are a bunch of differences, especially around the infrastructure services. The main point here with vSphere 7.0 U1 and vSphere with TANZU is that there are no pod VMs in the supervisor cluster. The pod VMs has a requirement on NSXT. Now, if you had NSXT, you could still use those, but vSphere with TANZU also supports the normal vSphere networking. So if you had a vSphere distributed switch, you could absolutely use vSphere with TANZU. So that's the major difference. And because we don't support pod VMs without NSXT, you also don't get the Harbor image registry either in the infrastructure services. But other than that, you have the ability to deploy TANZU Kubernetes grid guest clusters, and that whole experience is exactly the same between VCF with TANZU and vSphere with TANZU. But again, the major point, I guess, is that you don't have NSXT, thus you don't have pod VMs, and because you don't have pod VMs, you don't have the Harbor image registry service either. So these things along the bottom are a little bit interesting. Bring your own networking means you could use NSXT, but we do support vSphere distributed switches. It doesn't really matter what storage is under the cover. VCF has a requirement on using vSAN, of course, but you can bring your own storage. And this bring your own load balancer. Now, there obviously needs to be load balancer available for Kubernetes in order for Kubernetes to talk to the outside world. And what we are doing here is we are providing a HA proxy appliance that behaves as a load balancer for you. So let's just run down through the differences once again. As I said, with the VCF with TANZU, really designed for scale, for large-scale deployments. With that case, you obviously need VCF. You get NSXT, so NSXT provides a load balancer, provides pod traffic overlays. So there is obviously pod VMs. There is a Calico CNI. This is the networking component that runs in Kubernetes. And of course, you get the Harbor image registry as well. vSphere with TANZU then, no VCF required, no NSXT required. You use a VDS networking, the vSphere distributed switches. We provide you with a HA proxy to do the load balancing, but because of that fact that there's no NSXT, there's no pod VMs. Antria is our CNI in this case, or networking component in Kubernetes. This is a VMware product, but we can also support Calico. And because we have no pod VMs, we have no Harbor image registry either. So let's have a look at how we would deploy this new mechanism. I've stood up a very simple deployment here. This is just to give you an overview of the networking involved. Obviously, we have a vSphere infrastructure management network with your vCenter server. And there's 2 additional networks. There is the workload network, which is where your Kubernetes VMs, your TANZU Kubernetes grid guest cluster VMs get deployed to. And then there's a front-end load balancer network, which this is where your developers would connect to in order to communicate to Kubernetes. So think of your developers connecting to the purple network on the top there, the front-end load balancer network. So what we're going to do then is we just simply roll out the HA proxy. Like I said, we provide this to you as an OVA, so you just go ahead, deploy it, fill in the information about the different networks and so on. So you get a load balancer IP address range. You would have a range of IP addresses for the workload network as well. So you just provide all of that information. And when that's done, then we end up with something that sort of looks like this. So our HA proxy is a VM. It is on the management network. It is on the workload network. It is on the front-end network. So it's able to communicate to all 3 of those networks. So that's going to provide the load balancer IP addresses and also the IP addresses for the nodes that appear on the workload network. So the next thing we're going to do then is we're going to enable vSphere with TANZU. And so this is built into the vSphere client, and you run through and you select the cluster that you want to have vSphere with TANZU enabled on. And what we do in that point is we roll out a set of supervisor VMs, we call them our supervisor nodes. And this is essentially the control plane for the vSphere with TANZU supervisor cluster. So essentially what will happen eventually is it'll run out, it'll go through the configuring of those supervisor VMs, and when everything is up and running, what you will get is a control plane IP address on that load balancer network. And this is the IP address there, the 192.50 in this example. This is the IP address that your developers will connect to in order to communicate to vSphere with TANZU and work with vSphere with TANZU. So now we have something that sort of looks like this. So we have, by default, it's 3 supervisor VMs that get rolled out. They all connect to the management network, but they are also plumbed up onto the workload network because there needs to be a communication channel from the TANZU Kubernetes grid nodes to the supervisor nodes. Last but not least, these are all wrapped around in a load balancer IP, and there's a load balancer IP address associated with the supervisor cluster, which gets plumbed up onto the front-end network, and this is again the network that the developer would use to communicate to your vSphere with TANZU. So I have a demonstration that we can run through, and we'll show you this running in earnest. So this is now coming along, and we're going to actually configure vSphere with TANZU on a 4-node vSphere cluster. So this is basically, did that just reset? Okay, it's off again. Oh, it should just play. There we go. So this is just taking us through the settings. First, what we just selected there is the cluster. Now we're going to select control plane size. And you can see that there's various sizes there. But the video is a little bit choppy, but hopefully you'll be able to see that. And we're moving on now to the load balancer network. And we're filling in all the details for that load balancer network. Oops, that did not work very well. See if I can go back and do that again. Let's try that once more. Playing. Let's see. Okay, let's try it once more and see what happens. So it's workload management is how we set up vSphere with TANZU. And there we can see that we have the ability to select NSXT or VDS. Okay. It does seem to be very choppy. I'm not sure why that's the case. But essentially what you're doing there now, it seems to be running again, I hope, is selecting a storage class, filling in load balancer network details, because as I said, everything needs to come up. All of those Kubernetes API servers need to come up there. Something tells me this is not working very well. Okay, I think what we'll have to do is move on. For some reason, the videos or the demonstrations aren't working very well. So at the end of the day, once that has all been stood up, what you'll be able to do is build what are known as namespaces. And namespaces in vSphere watanzu are just a way of setting aside a set of resources that can be used by developers. So these could be CPU resources, memory resources, storage resources, and all of that good stuff. So this is a view of an already created namespace. And what you can do here is you can actually add permissions about who is allowed to, who has read-only access to this namespace and who can actually make changes to the namespace. Storage then is interesting because storage here is where you would select a policy, a storage policy that tells the developer who is using this namespace they are allowed to use this particular storage. But you can also go in under capacity and usage, and you can actually limit the amount of storage that they're allowed to use. The same goes for CPU, same goes for memory. You can actually place limits on all of those things. The last column there then just tells you whether there's any TANZU Kubernetes grid guest clusters deployed. At this point, there aren't any, but you have the ability also to select a content library. And a content library is where you would maintain the images that are used for deploying these TANZU Kubernetes grid guest clusters. So this is the overview of the namespace, and I think this is probably one of the most powerful concepts that we have with vSphere watanzu is the ability to carve out these namespaces and make sure that one developer or one development team is not stepping on another developer or development team. So when vSphere watanzu is all set up, the next thing we would do then is we would log in to vSphere watanzu. Now, there is a landing page that we can give developers for downloading all of these tools. So they can simply connect to a URL and they get these tools, kubectl, vSphere, kubectl, to actually interact with vSphere watanzu. So this is the first thing they would do. They would log in, and then what they would see is that any available namespaces, and hopefully you can see it here that there's a namespace that I created earlier, Cormac NS. So they're working in that context of that namespace. It's got its resources, it's got its limits, it's got its storage policies all associated with them. So the developers can now work in this area. They could work at the supervisor cluster layer, or they could build a guest cluster and then change contexts to work in the guest cluster. So let me show you how to do that. So to build a guest cluster, it's very straightforward. You just create a very simple manifest file in the YAML format, YAML short for yet another markup language. And what you do, just provide the name of the cluster, some topology information, so how many VMs are in the control plane, how many workers or have you available to you, or how many do you want to have, and so on. And at the last but not least, down at the bottom, a version that matches a version that you have available in the content library. So you would just use kubectl to apply this standard Kubernetes stuff again, and this will go out and it will build a TANZU Kubernetes grid guest cluster in the namespace that you are currently working in. So hopefully that makes sense. And so again, when you have deployed that guest cluster, you would change context. So you could log out of the current context and then log in with a new context, this time specifying the namespace and this time specifying the TANZU Kubernetes grid guest cluster. So provide a password, log in, and now you can see there's an additional context here, and you can work in that new context. So if we keep going, what we've just done by creating that new TANZU Kubernetes grid cluster with one control plane node and 2 worker nodes is we have deployed 3 new VMs. They're all plumbed up onto the workload network using IP addresses that are provided by the HA proxy. And we also plumb up the control plane onto the load balancer network. And once again, when we saw earlier that the developer logged back in, he would be communicating with that guest cluster using that new control plane API server. So I had another demonstration to show you that working. We'll give it a go. I'm not sure how it will play, but let's see what happens when we try to run this one. This one now shows us that our namespace has already been created. You can see it here. There's nothing in it yet. There's no resources being consumed. And I think this has gone choppy as well. So I'm not sure how well this is going to work at all. What I am showing you here is just logging out and using the command line to actually log into the cluster. Let's see if this behaves any better than the UI. And you can see that I've logged in there successfully. And the developer now can use kubectl commands to just interact. And you can see that at this point we were in the, I don't think that's working very well either. Anyway, I think we'll just have to leave those demonstrations for the moment. And we move on. So unfortunately, the demonstrations didn't work very well, but because I'm really focusing on the storage side of things, I did want to show you one last thing to do with storage in these vSphere with TANZU and VCF with TANZU deployments. And this is using our CSI driver. I'll do a little quick overview of how storage typically works in Kubernetes, especially when the Kubernetes cluster is running on top of vSphere in such an environment here. Typically what we have in this type of environment is that we have the CSI driver that runs in the Kubernetes control plane, and we have a CNS component that actually runs in vCenter server. And this is a communication channel between Kubernetes and vSphere. Now, if our developer comes along and our developer decides that they want to create a, let's say, some sort of stateful application that requires storage, in that particular case, there's for all intents and purposes, a VMDK is created. And that VMDK is actually a persistent volume in Kubernetes. It is our PV is what we call it. So when you're talking about persistent volumes in Kubernetes, they really relate back to virtual machine disks in vSphere. Now, the other interesting thing is that we can also have policies associated with those VMDKs if you're familiar with storage policy-based management. And this just simply means that we can elect to have that VMDK created on any vSphere storage type, whether it's vSAN, vVols, VMFS, or NFS. So the whole idea here is when that VMDK is created, it becomes attached to one of the worker nodes. And so it's just like a VMDK being attached to a VM, same concept here. The idea, though, is that it's not the worker node that needs to use the volume, but it's a pod, or to use, it could be a container within a pod. And so the final role here is done by this kubelet. It's basically a Kubernetes agent that runs in all the different worker nodes, and this kubelet is responsible for taking that attached VMDK and mounting it up into the pod or container. So that's basically the workflow, and our CSI driver plays a significant role in all of that. It is slightly different then when we start talking about vSphere with TANZU. So if we take our vSphere with TANZU deployment, we have our supervisor control plane as a set of 3 VMs. This is what we call our supervisor cluster. We build a namespace, and we might have some resource limit set on the namespace around CPU, memory, and storage. Now your developer logs in requests the creation of something in here like pod VMs, supervisor workloads, but maybe they want to be stateful. So maybe there needs to be stateful, it's a stateful application. So these pod VMs require some sort of storage. That's pretty straightforward to do because the CSI driver runs in the supervisor control plane. It's able to talk to vCenter server and CNS. They're all on the same management network. And any requests to do volumes, very straightforward. We can build those back on vSphere. And the very nice thing that CNS does for us is it shows all of this information in the vSphere client. So anytime there is a persistent volume created on vSphere storage, we're able to bubble up all of this information. So we can see a whole bunch of information related to Kubernetes and how Kubernetes is consuming storage directly from the vSphere client. So let's move on and let's talk a little bit about the guest clusters. We're going to build out our vSphere with Kubernetes or vSphere with TANZU once again. And at this point, we've built a TANZU Kubernetes Grid guest cluster. Now the developer comes along and he wants to create persistent storage volumes once again. The interesting thing here is that there is no path from the control plane in the TKG to vCenter server. So what we have to do is a level of indirection for these pods that require persistent storage. In each TANZU Kubernetes Grid guest cluster, there's a PV or a paravirtual CSI. That paravirtual CSI talks to the CSI driver in the control plane, and that talks to CNS on behalf of the TANZU Kubernetes Grid guest cluster. So once again, there's a request to build storage for these TANZU Kubernetes Grid guest cluster applications. There's just a level of redirection that needs to take place in order to do that. But fully supported, we can do stateful applications in the TANZU Kubernetes Grid guest clusters as well. And how that is shown in the UI, there is that level of indirection represented in the UI as well. You can see all the details about the guest cluster, the guest namespace, but also the supervisor cluster in which the guest cluster is running. So you get all of that information bubbled up. Very useful for management purposes, for sure, monitoring purposes, and also for troubleshooting purposes. So I'm going to leave you with this final slide, and this is just an overview of where we have come from with our CSI driver. The initial release was with vSphere 6.7U3. It was the CSI 1.0. We only had block support back then, and we didn't have vVol support either. Coming in the 7.0 release, we had file-based PVs using vSAN file services. We introduced vVol support, VM encryption support as well, and the ability to grow volumes offline. In the 2.1 release, coming with vSphere 7.0U1, the particular focus was vSphere with TANZU and the ability to do static PVs in both the supervisor and guest clusters and the offline volume grow as well. And last but not least, we included a volume health feature. So you're able to query from kubectl the health of any volume that has been provisioned on vSphere storage directly from the kubectl command. So that's it from me. Hopefully that's giving you an overview. A shame that the demonstrations didn't work. I'm not sure, probably again, just the lag with doing things remotely like this. But hopefully it's given you an idea of what VCF with TANZU provides, and now also what the new vSphere with TANZU provides. No longer a requirement to have VCF, no longer a requirement to have NSXT, but there are some features that you don't get, such as the pod VM construct, if you go with the vSphere with TANZU using the HA proxy. So I'll leave it there, and I think we might take any questions that have arisen from the presentation.
Hi, we're back. Thank you for your presentation. And for the questions, I have Tomasz in here from VMware to help me with that.
Tomasz.
So, Tomasz, would you introduce the first question?
Okay, so it's like two questions in one and kind of important. Is it possible to use vSphere TANZU supervisor cluster to deploy a guest cluster in a public cloud?
Yeah, so I believe there's work done to implement that in VMC with AWS. That is my understanding. I'm not 100% sure, but at least I believe that there is definitely work underway to implement that on VMC with AWS.
Yes.
It may already be there. I just it's not an area that I've actually focused on.
Thanks.
So
there is also a question. Yeah, there is also a question to compare. It's written like PKI and TANZU, but I believe it means PKS and TANZU. So can you briefly like compare PKS and TANZU?
Yeah, so I think, yes. So that's a very good question. So PKS, or Enterprise PKS, is now being rebranded as TKGI, I think. So it's essentially the same as PKS was previously. At the end of the day, they both achieve the same thing. They're both there for deploying Kubernetes clusters. I think what you have with Enterprise PKS, now TKGI, is the ability to have lots of different flavors of Kubernetes. So you could choose different versions of operating systems and so on to be able to deploy out your different Kubernetes clusters.
Right, and
with
obviously.
TKG. Go ahead.
So, and there is no vCenter UI integration for TKGI.
Indeed, there is that as well. The one thing with the TANZU Kubernetes grid, they are all based on Photon OS at the moment.
Okay.
So
the next
one difference, I guess.
The next question we have here is that since the vSphere with TANZU has no pod VM, what we are using to deploy containers? Is it standard Linux VM? Can you be more detailed on that?
Yeah, so there's no pod VMs in the supervisor cluster, so you will not be able to deploy any containers in the supervisor cluster. What you have the ability to do is just deploy the TANZU Kubernetes grid guest clusters, and then you would just be using native containers in the TANZU Kubernetes grid guest. Right. So you can't do any pod VM work in the supervisor cluster with vSphere with TANZU using the HA proxy. Okay. Now, having said that, if you had NSXT, you could absolutely use vSphere with TANZU with NSXT and still use the pod VM construct. But there is a requirement for the pod VMs to have NSXT at the moment.
Right. So vSphere and NSX customers can go and use pod VMs with vSphere TANZU, right?
Absolutely, yes, correct.
The next question is, what license is needed for the VDS functionality? I guess it's Enterprise Plus for the installation without the NSX.
Right, I think there is there's a license for vSphere with TANZU as well. But what we do is we ship with a 60-day eval. So if you wanted to try it out, there's a 60-day eval that you can try everything out with.
Right. You mentioned HA proxy is a part of the solution. How we ensure high availability for HA proxy? Do we use like vSphere HA, or there is some internal mechanism?
So there is nothing built into the HA proxy at the moment that we have that we support. So it would be just something like vSphere HA. Okay. I know you can get HA proxies come in different configurations to provide high availability, but we don't provide that with the HA proxy that we're providing with vSphere with TANZU.
Yeah, there is a funny question. Do we have plans to introduce TANZU on ESXi for ARM?
Who knows? Who knows?
All right.
Maybe. It's there's a lot of exciting things happening with ARM at the moment.
And maybe last question, do you plan to write a book again about the TANZU?
No plans, no. But I do a lot of blogging about it, so, okay. You know, same thing, yeah.
So the blog is the safe place. Thanks.
Okay. That's all for the questions, and that's all for you now. So thank you very much for connecting to Prague, and enjoy your time in Cork.
Yeah. Thank you.
Thank you.
Bye.
Bye bye.
Everyone.
A já děkuji Tomášovi.